Hello and welcome to STEM Pursuits with Mr. Clausen. Today we are going to talk about dividing polynomials using long division. So specifically what I want to go over with you today is talking about how we divide polynomials using long division. And one of the practical applications of this is if we're looking at situations where we want to evaluate specific factors, so binomials for example, x minus a type situations. If we have a binomial that we want to figure out is an actual factor, we can go and we can test it using long division and then look at whether that binomial can be factored out of the polynomial as a given example. So let's look at a couple situations so I can show you what we're talking about and look at how we can divide binomials out of a polynomial. And this is really useful when there's not necessarily a common factor we can pull out. So like I'm looking at this specific polynomial here. There's not a common factor we can pull out. There's nothing really easy that we have access to. So now what we have to do is we have to look at other division methods to see if something like, as an example, can be divided out and we can find what the actual solution is. So when we have a situation like this, we want to be able to divide this out, and just like any other situation where if you're pulling 4 out of 32 as an example, you've maybe seen this before, and really the idea is this is how many times can you pull 4 out of 3? Well, 0 times. And how many times can you pull 4 out of 32? Well, if you go, we can say 8 times 4 is equal to 32. We try to match up that number, and usually when we did like short division, we're just trying to match the number. We take the opposite of it, and then if you have a remainder of 0, you know that 32 divided by 4 is equal to 8. Okay, so we're going to take that same idea, but we're going to apply it to a binomial being pulled out of a polynomial. So in this specific case, what we're going to do is we have x minus 4, and we're going to pull that all out of 2x cubed minus 3x squared minus 18x minus 8. So this is the situation that we're dealing with, and then we're just going to find the factors on top of here. So just like we did in short division, what really we're going to try to do is we're going to try to tack out each of these factors one at a time. But the thing that you have to keep in mind of when you're trying to divide a polynomial is you always have to deal with this highest power component of a polynomial first. So how do we do that? Well, what we're going to do is that we're going to look at this x term here, and we're going to go and ask the question, how much do we have to multiply with this x to get 2x cubed? Because if we don't deal with the highest ordered power right away, then we're not going to be able to deal with the rest of the problem. So in a lot of Algebra 2 textbooks, we look at it from a perspective of is if we go 2x cubed and we divide it by the leading term of the binomial x, and we get 2x squared, we need to multiply x by 2x squared in order to get 2x cubed. Okay, so let me just write that here, and I'll show you kind of what that looks like. Because again, the idea is if we multiply x times 2x squared, what we're going to get down below is we're going to get 2x cubed. And we have to deal with that first. We have to focus on the highest powered part of the polynomial. Okay, so if we multiply x by 2x squared, we'll get 2x cubed. And now if we multiply 2x squared times negative 4, then we're going to get negative 8x squared. So we're dealing with the cubic term here by doing this, because just like we would do with short division, what we're trying to do is match up the numbers. So really what we're going to do is we're going to subtract this from this part up here. And after we do the math, we'll see that these guys cancel. And we have the negative 3x squared here, but after we add the 8x squared here, and it's adding because we have a minus, get the clunk and change both of these to pluses. And then we're going to have 5x squared. and we'll drop the 18 down here. So we'll go negative 18x, and then we'll go on from there. Okay, so what we're going to do is we're always going to deal with this highest power first. And then what we'll do as a result is that we'll just deal with whatever consequence results as a part of making that decision. Because if you don't deal with the highest power, then you're stuck, right? So now I'm going to look at this 5x squared because this is my new highest power. So if I take the 5x squared and I divide it by the highest power portion of my binomial, I go 5x squared, I divide it by x, okay, and this will just equal 5x. And if you can just see that 5x times x gets you 5x squared, that's fine. This is just a way that you can always do it. And what this is going to allow us to do is just say, hey, if we say plus 5x, now what we're going to do is we're going to go 5x times x, and that'll get us 5x squared down here. And we'll go 5x times negative 4, and that'll give us negative 20x. And it's close, but no cigar. So what we're going to do is we're going to remove this, okay, just like we do with short division. You know, whatever, we're just trying to match everything up. So really what we're doing is we're taking the difference from the bottom here. Those cancel. And if you don't match that up correctly so they cancel, you did something wrong, okay? Now the second half, if it does, awesome, but if it doesn't, you know, that might not be a bad thing. So we're going to look at this and we're going to say, all right, if we go negative 18 plus 20, okay, because we're distributing that minus sign, remember, plus, and then we're going to go 2x, and now we're going to take the 8, we're going to drop it down, go negative 8, and now we have this nice situation where we have 2x divided by x is equal to 2. So now we're going to go plus 2. And if we go 2 times x, that's 2x. We go 2 times negative 4, that's negative 8. Hey, it all matches up. You have 0. And this is what your remainder is this value right here. So we have a remainder of 0. So literally what this means is that, hey, if we go x minus 4 times this trinomial, we would get that polynomial back. Okay, so your final answer, technically, if you were looking for one, is you would say 2x squared plus 5x plus 2 is the answer when you divide x minus 4 from this polynomial. Okay, so again, looking at this, the main thing is whenever you're using long division is you're just trying to knock out these highest powered components first and work your way down until there's nothing left. And if you have a remainder of 0, that's awesome. If you do have a remainder, you would state that. And normally a lot of textbooks will do something like this, where they'll do a uppercase R, and you'll just state that as part of your final solution. So I would typically write something like this, where you write out the new polynomial or trinomial that forms, and then just say remainder, capital R, semicolon 0. And that's how I would state it. So let's look at a really useful application of long division. So long division can actually be used to divide any polynomial. We're going to talk about a technique called synthetic division in the next video. But the nice thing about long division is that you can actually use long division even if you have more complicated binomials. So specifically what I mean is that you have a coefficient here of 3, which usually makes things a little bit more difficult. But in this specific instance, it's not going to make any difference. So I want to show you this as an example because this is a little bit more technical of a situation. And if we go and we write all of this out, and we go 3x to the 4th power minus 5x cubed plus 2x squared plus 3x minus 2. So we got a pretty big 5-term polynomial going on here. And just like I was talking about before, we have to deal with this highest power first and then divide it by the higher power portion of the binomial. okay? Because just like we would do with short division, what we're trying to do is get things to match up. So if we look at this situation and go 3x to the 4th power and we divide it by the 3x, what we're going to see is that the 3's cancel, one of the x's cancel, and this turns to a 3. So x cubed is going to be what remains. And again, the idea is if we go x cubed and we multiply that by 3x, we're just trying to reproduce that scenario. So that'll give us 3x to the 4th. This matches up. This is exactly what we have to have happen so that they cancel. And then we're just going to deal with everything else as however it falls through. So x cubed times negative 2, that's going to give us negative 2 times x to the 3rd power. And again, just like I showed you with short division or in the previous example, we're really just subtracting this from the part up above. You don't have to write the minus sign here. I just find students generally find it easier to kind of figure out what they're supposed to do because it looks a little bit different than short division. But you're just trying to match it so it cancels. And now we're going to go negative 5x cubed. And since we're just taking away the difference here, negative 5x cubed plus 2x cubed is going to give us negative 3x cubed left. Now we're going to drop this down and go plus 2x cubed. This equals 0 because it has to. And now what I'm going to do is I have negative 3x cubed as my next term. Well, what do I have to multiply 3x by in order to get 3x cubed? Well, let's go 3x cubed and divide it by 3x, and then we'll find that out. So again, boom, 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 and we'll get negative x squared as what we would need to create that term. So that's what I'm going to go put up here because that's what I need to cancel out. Negative x squared. And negative x squared times 3x is going to give us negative 3x squared, or cubed. You got to get that to match up. If it doesn't match up, it's not going to work. And now what we're going to do is go negative x squared times negative 2. That's going to give me positive 2x squared. Boom. That is awesome. Both terms match up. Kachiga, kachiga. All right. All goes away. And now you have 0 plus 0. Nice. Okay. And now that you have this situation arise, we're going to go and drop this down. And one thing you'll notice is that there's no x squared term. So technically, we don't have to deal with that. So a lot of times what I'll do is I'll just put a 0 here for now because I didn't have to do anything there. If you want to just write the next thing, that's fine as well. So now what I'm going to do is I'm going to drop these next two terms, or I could just leave them up there. And I see that 3x minus 2 is what I have left. So if I just say plus 1, 3x minus 2, 3x minus 2, remainder is 0, I see that the result of dividing this polynomial by this binomial is simply just x cubed minus x squared plus 1 with a remainder of 0. And that would be your solution. So now we just took a really complicated quartic polynomial, and now we've simplified it to a cubic trinomial. So we have a significantly easier scenario on our hands in this specific instance, and we can try to look for other roots and those type of things. So application where you might use this just maybe a little more randomly is if you get asked a question like, evaluate whether a polynomial has a factor of -2, or maybe we're trying to say a binomial x plus 2, because commonly if we look at a situation like this, what this binomial would suggest is that -2 is a root of a polynomial, or a point where it crosses the x-axis. So if you wanted to check that and see if that was the case, we can just simply divide this cubic polynomial by this binomial. And if the remainder is 0, that means that -2 is a root. Okay, so this can be a situation where you would want to actually plug it in and check it super quick. So we could go x plus 2. We can use our long division setup. And once you get the format, it takes going through the process a few times to get used to the variation that's there from like normal short division type problems. But I see this and I can see, all right, x squared times x will get me x cubed. So I'm going to get x cubed plus 2x squared. Okay, this will give me 2x squared left. Drop this down, x. 2x squared plus 2x. 2x squared times x is 2x squared. 2x plus 2 times 2 is plus 4x. All right. That cancels. Now, remember that this really distributes, so this turns into a minus sign. Really, if you're thinking about it in terms of like the difference, or again, if you don't need that, don't feel like you have to use it. I just find students gravitate towards that a little bit better. And then in this situation, x times -3 is what's going to cause that to cancel out. And now if we see that we plug -3 in for x, that'll give us -3x. 2 times -3 is -6. That all goes through, and we get 0 as a remainder. So if you get 0 as your remainder, okay, if remainder is 0, then the binomial is a factor. And if it's not equal to 0, that means the binomial is not a factor. Okay, so keep that in mind. A lot of times you're trying to get 0. I mean, it's always nice when that happens and everything, like, oh, but that's not always the case. So keep that in mind. But if you have a problem that wants you to test if a binomial is a factor, you just plug it through, and as long as the remainder is 0, then you know that that's a factor, and the -2 would be a root for this specific situation. I hope this video was helpful and that you now have a better understanding of long division, and that you have a great rest of your day. Peace out.